Ender, great to have you. Martin, welcome. So, take a seat, gentlemen. Make yourselves feel comfortable. Welcome. Did I pronounce your name correctly, at least?
Yes.
Yuezbasioglu.
Yeah.
All right, good. Nice to have you.
Absolutely.
And Martin, now, we checked out this video. Maybe you can, before we deep dive into the topic, tell us briefly what you actually do at Voestalpine and, of course, at Siemens.
Okay, I start as product portfolio manager in HMI app business unit of factory automation. I am responsible for several industrial edge apps, including Industry Information Hub, which is the integration layer between IT and OT, as well as connectivity apps, which are used to collect shop floor data. I strongly believe that they will help our customer Voestalpine to tackle their challenges.
All right, and how about Martin?
Thanks a lot for the introduction, Chris. And I'm responsible for IT and automation in our company. And we currently tackle to find a solution for edge and edge management in the past. And that is what I would like to introduce a little bit in the next slides to you.
All right. So maybe you want to start it off, I don't know, with a video I think you brought along?
Exactly. I would like to start really with some impressions about the challenge what we faced and some background information that you have some knowledge first.
All right, so let's play it.
Seen in this way, a saw is not just a saw. It is a saw blade which has cut 124,340 square centimeters of high alloy steel at a speed of 60 meters per minute and at temperatures of up to 650 degrees Celsius over the last 98 hours. Collecting and analyzing this data can tell us a diverse range of things. For instance, that the saw blade will rupture in 21 hours, time enough to foresee a planned exchange of the saw blade. Beyond that, it enables us to determine the most fitting blade type for a specific order, the automatic reordering of the blade, the optimization of the production plan in order to increase the output, and much more.
Wow. Now, that is impressive, at least from the facts that stuck watching this video. You got to tell me, what are the main challenges here, and how did Siemens help address these?
As you already described, we was founded new as a company, and we started with a growth mindset because this is in our natural DNA. We would like to grow in feature-based as well as in scalability. And for this, we target currently really to establish a future solution, a future-proven solution which can be scaled up in capabilities, which in features, as well as in quantities overall. Because as you mentioned already, we're talking about a global scalability because we have still our facilities out there, and there are more than hundreds out there.
Right, right. So you're the go-to guy, I guess, for Voestalpine. You're the industrial edge expert, product manager for industrial apps. Maybe you can briefly explain the offerings, the tools that actually helped address these challenges that Martin just mentioned.
Yeah. Let me show you this slide. So industrial edge stands for an open and ready-to-use edge computing platform consisting of edge devices, edge apps, edge connectivity, and a management infrastructure for apps and devices. Industrial edge brings edge computing to the industry. With edge computing, the data is processed where it is created at production machinery, machine tools, equipment, and processes. Thereby, you can finally make sense of this data to optimize your processes, to save resources, like in the case of Voestalpine, saw blade utilization, or improving the quality. With industrial edge, you can also use cloud computing if required. For example, to benefit from higher computing power, more storage space, or remote access. Thereby, you have full control over your data at all times. Industrial edge enables embedding of information technology and data layers, databases, and artificial intelligence into the control plane. They bring innovative applications in the area of diagnostics and the analysis of large and high-frequency data volumes in the manufacturing and automation environments, such as predictive maintenance. The apps can be provided by the partners. In case of Voestalpine, a FANUC connector is a very good example. This is provided by a partner or directly by Siemens as well. And they can be also developed customer specific based on the individual requirements. The in-house development of industrial edge is based on the Docker technology, such as using the programming languages C, C++, C#, Node.js, Python, and Java. And thanks to the use of container technology, industrial edge apps can run on various industrial edge devices without any limitations and compatibility issues. In that context, I want to show you this slide, as IT and OT integration plays a key role in terms of for the challenges of first IP. I would like to explain you how IT and OT integration works by the help of industrial edge apps on the top, the integration layer in between, which is the industry information hub, and broad range of connectivity at the bottom, which is the basis. Industry information hub creates an open ecosystem for agile and autonomous plants. Using semantic data models, you can capture production data from all around your enterprise to set the course for digitalization. You lay the foundation for the adaptiveness, which is playing a crucial role in terms of resilient industrial operations of the future and expansion of your digital operations at the end. IIH, in a nutshell, is data integration made easy for digital manufacturing. The central element, the core element of Industrial Information Hub is the integration layer. This is an integration system for all value-added applications. In IIH, the information is brought together by the help of a semantic model, which is created automatically. Thereby, you have full control of on your data management by collecting data from various data sources, pre-processing, and neutralizing live as well as historic data, and at the end, turning data into information by the help of the apps. That facilitates integration of the new plants and machines into the existing structures. To make it concrete for the overall story, based on the use case we prepared for the booth here, I want to give you an example based on the first IP in energy management use case. This is not rolled out yet. There are 3 PLCs. We are collecting energy consumption data from 3 different PLCs, Beckhoff, Rockwell, and Mitsubishi, third-party PLCs, through 3 different industrial edge connectivity apps. The energy consumption data is brought together by the help of a semantic model in Industry Information Hub in the integration layer. And Energy Manager on the top consumes this data to optimize the process and to show the energy management data or energy consumption data. The next step is to roll out this use case at first IP by extending an existing process utilization tool, which is already in place, which Martin will explain in more detail in the next few minutes.
Okay, now, wait a minute. Let me think about that. If I try to break it down or put it into lay terms, it's kind of like you're offering certain ingredients, all right? And the customer can basically choose what he needs depending on the applications, depending on the devices, whatever, depending on the industry. All that is, of course, prerequisite. But and then you, as a customer, can basically create your own tools in a way with the guidance of Siemens, with the help of Siemens.
Yes.
It's kind of like you're having a prep meal package, just waiting to be thrown into one pot meal, so to say. What tools did you come up with?
What we have done so far, and can we show this next slide, thanks. Let me rephrase first what Ender described.
Yeah.
We're talking about the data collection layer, the data preparation and integration layer because of this edge device where the application will be hosted, and then the presenting layer about the application front ends for the customers. Our customers need to view the data as well. This is the advantage of the solution. When you go deeper in the solution, we start on the lowest end where we integrate really PLC data on raw data signals on sensor data. That data will be offered on OPC UA interfaces to collect on the edge device layer. Here we host different applications to transfer the data, interpret the data first, and transfer the results further to the cloud, where we host already different applications to utilize the data which we have collected. Next to this, it's mostly important to have it manageable. Yeah? If you think about 100 locations on a globe scale, you must manage the edge devices as well. And for this, we use really the edge management application, which is hosted centrally, where we centrally manage the application as well as keep the operating system up to date. This is a key success factor also for our application, which we currently run in multiple locations at the moment globally. Next to this, we would like to extend, and with this extension functionality, we talk about energy management.
Oh, sorry.
And here you can see some examples where we think about to make it scalable in future when we're talking about features. We see this as an application container, and this application container will be also hosted on the industrial edge device itself, where we talk about the data integration layer. That can be, for example, fan controls, that can be other applications as well as officially front-end application for the customer directly. Therefore, we talk about all these three layers. Modularity is highly success factor for us to scale it up for the future and keep it proven.
Sounds impressive. Maybe you can try to outline the benefits for the audience here once again, and maybe also just tell us a bit about what you're trying to tackle together in the future. What other plans are there?
At the moment, we started really with transparency in the shop floor areas, where we first gather the data, bring the data to the customers, where they run their own processes to improve. But next to this, we would like to further improve this case, for example, for energy management. It's highly important to know also about data consumption, as well as energy consumption. This is highly required to extend this feature in future, as well as all this modularity about how to make the data modeling itself, which data should be collected and interpreted for. This is highly important. As well as for our scalability, the ecosystem, we need also different suppliers who can support us with different software packages in future, as well as the whole pack on industrial used applications, as well as hardware infrastructure is highly recommended, and that's really the benefit out of the solution.
All right, so looking at the time, 30 seconds left. That brings us to the conclusion that if you have any similar challenges, ladies and gentlemen, feel free to approach Martin and Ender, or Martin or Ender, and they'll be glad to help you out. But I think they deserve a big round of applause here. Thank you very much, gentlemen, for being here today, and much success in the future. Sounds like a great collaboration. Thank you.
Thank you.